A is not too difficult. Basically, A is just saying we have a zip line. This is a zip line supporting a person whose weight is 200 pounds, is attached at 2 points by a cable. So this is a cable that they're using to go down the zip line. And then the geometry and free body diagrams are shown basically in both of these. This is the free body diagram. And this is the picture of really what's happening. Determine angle theta 1 and theta 2. They're giving us some information that allows us to find theta 1 and theta 2 because we're going to use that to do the free body diagram. So we're going to start off by saying that, well, we know this is equal to 9.75. And these are both 20, and they're all in feet, and H2 is 5. Now I can find theta 1 and theta 2 by just using my tangent because I have opposite over adjacent. So again, I have tangent of theta 1 is equal to 9.75 divided by 20. And then we're going to take the inverse of both sides, which leaves theta 1 equal to the inverse tangent of 9.75 divided by 20. And let's get our calculator back. I have the inverse tangent of 9.75 over 20. Again, I'm in degrees. My answer is 25 point. I really want to say 26, but I'll say 25.99. I think that's sufficient. My angle is 25.99, and it would not upset me if we rounded this to 26. You know what? I'm going to round it to 26. If we need more accuracy, I'll definitely write that on the problem. Let's just make this 26 degrees. It's very close. And then B, I can just say theta sub 2 is equal to the inverse tan of opposite over adjacent, but now we're on the other side, so it's 5 over 20, which is really the same as 1/4. Let's get the calculator back. I'm going to round this to 14 degrees. So now I know a little bit more about my picture. I'm going to keep writing without erasing, but we might lose our picture at some point. Actually, that's all A. This is not B. That is all of A. It says determine angle theta 1 and theta 2. I have theta 1 is equal to 26 degrees. Theta 2 is equal to 14 degrees. Here I have B. And I'm going to redraw that down here so that I don't have to worry about it going off the screen. So here's T2. Here's T1. And the person's weight on the zip line is going straight down. Weight always goes straight down. We know this angle is 26 degrees. And we know this angle is 14 degrees. And obviously that one is going negative 90 degrees, the one at the bottom. And that's really all the information we have. What we're trying to do is find out the forces on the cable due to the angles that the cable are at the moment and the person's weight. If it was a child in that seat, it wouldn't be pulling on those cables as much as a 200-pound person. So we're trying to find how much tension is in the cables. Now, this would be probably really important if you knew that the cables could only hold a certain amount of weight. You can find what the maximum weight a person could be so that the cables don't snap. Now, everything that it said before for A was just to find the angles. Now we want to find the X values and the Y values for T1, T2, and W. And what I have to do is I have to break each one of those into its component form. Remember, these are triangles. I know that I can now break this up into X and Y values. Let's do T1 first. T1 in the X direction, this is T1 in the X direction. It's going to be equal to the adjacent over hypotenuse. I'm going to find T1x. I know the cosine of 26 degrees because I want the X value is equal to the adjacent, which is I call T1x divided by the hypotenuse, which is T1. T1x is equal to T1 times the cosine of 26 degrees. Now, of course, you could put it in your calculator at this point and find out what the cosine of 26 degrees is, which is going to be a decimal, and you're going to have to carry that for a long time through. And then you really do need to worry about how many digits you carry it to. But if I leave it like this, I don't have to worry because I can do it later. So I know that the sine of 26 degrees is going to equal, and I'll call this T1 sub y. 26 degrees is equal to the opposite, which is T1 sub y over T1. So I can say T1 sub y is equal to T1 times the sine of 26 degrees.
Quick question.
Absolutely.
Is the reason we're not worried about the like the D1 and H1 from the first part because we're trying to figure out the forces in general, not for a specific length?
Yes. Why don't I have any information about the forces? Well, because 9.75 and 20 are just feet. I have to compare the same things to the same things. And if I'm talking about weight, I'm talking about a force. If I'm talking about a force, then I have to compare all the forces to each other, not the distances. Does that make sense?
That does.
I'm going to rewrite this in a much prettier form. I'm going to say T1 is going to be equal to, this is my value in the X direction. T1 equals T1 times cosine of 26 degrees plus T1 times I. This would be the sine of 26 degrees. This right here is my X value, and this right here is my Y value. Now I want to do the same thing for T2. And I already know the format it's going to be in, right? I can just almost copy what I did here. T2x is going to be equal to T2 times the cosine. This time it's of 14 degrees because that's what's on the other side. And T2y is going to be equal to T2 times the sine of 14 degrees. I can come back over here and write, I can come back over here and say T2 is going to equal T2 cosine of 14 degrees. I'll put the I in a minute. T2 sine of 14 degrees J. And then the last thing we're going to do before we start solving things is I'm going to find the weight. And since he weighs 200 pounds and the weight is really going straight down, and since it's going down, remember it's going to be minus 200. We can break it into sine and cosine, but because it's negative 90 degrees, the cosine is going to be 0, which is obvious that it's not going anywhere in the X direction, that it's going straight down. I'm going to say J, because that's really what it's doing. We have actually everything we need. Now, what we want to do is we want to find T1, T2. First, we'll find T1 and T2, and then we'll put them in rectangular form. These three equations are what I need. I want all the forces together to equal 0. If you have two teams and they're doing a tug of war, there's one team on one side, one team on the other side. As long as I keep their forces equal, nothing's moving. In a tug of war, we would only have two sides. We'd have a group over here and a group over here. And let's say this is the middle point. This middle point will not move as long as the forces here are equal to the forces here. This would be a force going in the negative. Let's say this is the negative x direction. This is the positive x direction. If I add them together, then it would be 0 as long as they're both the same x. That's basically what we're trying to enact here, only we have 3 forces. How are we going to do that? Well, I know in the x direction, the only thing I have is 2 variables. I know it has only to do with T1 and T2. I can say T1 times the cosine of 26 degrees. We don't even need to put the I in. We know it's in the x direction, so we're just going to set them equal to each other. So T1 cosine of 26 plus T2 cosine of 14 degrees has got to equal 0. This number right here is going to be negative, and this number right here is going to be positive. So I just want to set them equal to each other. T1 cosine of 26 degrees is actually going to equal T2 of cosine of 14 degrees. Okay. I'm going to divide both sides here by cosine of 26 degrees, cosine of 26 degrees. And now I actually found T1 because I'm going to cancel this, and I'm going to say T1 is equal to T2 times the cosine of 14 degrees divided by the cosine of 26 degrees, which is actually very helpful because it's going to be a lot easier to do this than a system of equations because I don't want to get all these decimal numbers. Okay. I'm trying to be very methodical here for you guys. I want to make sure you understand everything I'm doing. I want to do the exact same thing only for the J values. I know that T1 times the sine of 26 degrees, and the sine of 26 degrees, because even though it's the reference angle, I don't have to worry because the sine is the y value and both of these y values are going up. So if I can say that the T1 sine of 26 plus T2 sine of 14, and then that's got to equal the same thing as my weight. I could put that on the other side and say minus 200 equals 0, which is what I did before. T1, let's call this A and B and C, just so I don't have to write that whole thing. So let's call this A and this B. These are both the parts that are pulling straight up, and they've got to equal C. I have a system of equations. I'm going to use this to do substitution just because I don't want to carry around a bunch of decimals. That's the only reason. If you want, you can solve for cosine of 14 degrees and run through all your decimals and make two systems of equations and you'll be fine. But I don't want to run around with the decimals. So I decided not to do that. We know what T1 is in terms of T2, so I can substitute. So I have T2 times the cosine of 14 degrees divided by the cosine of 26 degrees. That's T1 times the sine of 26 degrees plus T2 times the sine of 14 degrees equals 200. And let's factor out a T2, and I end up with cosine of 14 degrees. Notice that the sine of 26 degrees over the cosine of 26 degrees is the same as the tangent of 26 degrees. So that simplifies this a little bit. And then I have plus the sine of 14 degrees equals 200. And I'm going to divide both sides by cosine of 14 degrees, tangent of 26 degrees, plus sine of 14 degrees. And that's going to cancel out all of this. And when I'm done, I should know what T2 equals. So let's get our calculator. So here's 200. And then we have negative cosine. And am I in degrees? Yes. Negative cosine of 14 degrees times the tangent of 26 degrees plus the sine of 14 degrees. I found my error. Because this cosine is positive and I have T1 times it, it looks like it's going in the same direction as T2, but it's not. So here, this should actually be negative. Yes. And then if that's negative, then this would be positive, and this would be positive. Here, instead of T1 equaling negative T2, it would equal positive T2. This is positive. And then this would be positive. This is where things might change. Okay, let me recalculate. So instead of this being negative, this is positive, which does change my value, which actually makes a lot more sense. Now I have something a little more reasonable, 279.66. Okay, now we've got something that actually seems reasonable. Now we know T2. Once we know T2, we can find T1, because T1 from right here is T2 times cosine of 14 divided by cosine of 26. T1, we already know is from here is equal to T2 times the cosine of 14 degrees divided by the cosine of 26 degrees. And let's get our calculator. Then we get really precise answer. T2 is that. So I'm going to multiply this whole thing. I'm just going to keep that there because that is T2 times cosine of 14 degrees divided by cosine of 26 degrees. And there we have our answer, 301.9. 301.9. 301.9. Now I know T2 and I know T1, and I of course know W. W is equal to negative 200 J. And I think it asks us to put both of these in terms of rectangular. So we know the magnitude of T1. We know the magnitude of T2. We know the angles. So let's really redraw everything one more time. I think this was T2 and this was T1 and this is W. We know this is 26 degrees and this is 14 degrees. So now I know my magnitude of T1. I know my magnitude of T2. This is pretty easy to find since it's just going in the negative y direction. There's no x value associated for us. T1 is going to equal 301.9 times the cosine of 26 times I. This is minus. T1 is equal. This is negative because I'm going in the negative x direction. Plus, and the y is going in the positive direction. So I can say 301.9 sine of 26 degrees J. And now it's probably a good idea to change it into decimal because I think that's what they do want. I have, let's get the cosine of 26 degrees times 301.9 is 271.35 negative 271.35 I plus sine of 26 times that. That's right. So I have 132.34 J. And that is T1 in rectangular. And then let's do the same thing for T2. And then we're going to look at our results because I really want you to understand what the results mean. T2 is going to equal, T2 is 279.66 times the cosine of 14 degrees I. And they're both going in the positive direction, 279.66 sine of 14 degrees J. T2 equals cosine of 14 degrees times 279.66 is 271.35 code 67.66 J. Okay, and there's my T2. T1 in rectangular form, T2 in rectangular form, and W in rectangular form. Now, I just want to point out something here, but notice the X values are exactly the same. They're just going in opposite directions, which is exactly what should be happening. If those X values weren't the same, then this guy is going to be swaying side to side, right? Because it's going to be pulling one way or the other. So we want it to be 0. And also, notice if I add my two Y values together, I get 200, which is exactly what I need to counteract the negative 200. And so everything looks right, and I feel like we're complete.